Hello everyone, today let's take a look at a relatively simple combinatorics question, Quantipus number 26, and we're just being asked how many of the first 1000 positive odd integers have distinct digits. So to answer this, let's just start with single digits, our easiest case. We know that the single digit positive odd integers are going to be 1, 3, 5, 7, and 9. And we know that an integer is going to be odd when it ends in one of these digits. So obviously there are 5 single-digit odd integers. Now let's count the number of 2-digit ones. Well, we know we have 2 places, the tens place and the ones place. And we know that our tens place digit cannot be 0, so it can be anything from 1 to 9. And then our ones place digit has to be odd to make it an odd number, so it has to be 1, 3, 5, 7, or 9. And we also need these integers to have distinct digits, which means the ones place cannot be the same number as the tens place. So since our choices for our ones place is basically a subset of the choices for our tens place, let's choose this. First, we know we have 5 different ways to choose that. And then once we've chosen one of these, we can cross it off from our selections over here. And we're going to have 8 ways to choose the tens place. Now 8 times 5 is going to equal 40. So therefore there are 40 2-digit positive odd integers with distinct digits. Another way to think about it is I have 9 digits for my tens place and 5 for my ones place. So we multiply this together to get 45, but then we need to subtract off the cases where our ones place is the same as our tens place, which is just going to be all the combos 1, 1, 3, 3, 5, 5, all the way down to 9, 9. And there's going to be 5 of those. So we can subtract off 5 and get 40 as well, but this way is much harder. So we've counted our single digits, we've counted our 2 digits, now let's count our 3-digit numbers. So these are what our subsets look like, obviously an odd number in the end, and this middle number can be anything 0 through 9, and then this one has to be 1 through 9 because it cannot start with a 0, right? A 3-digit number can't start with a 0. So let's start by choosing this. We know that there are 5 choices here. So once we've chosen this one, we cross off one of the valid options in this subset. So we're going to lose 1. We had 9 originally, right? 1 through 9. So we need to subtract 1 and we get 8 choices for this 100th place. So once we've crossed off one of these and one of these, we've crossed off 2 choices for our final remaining digit, of which we originally had 10. So this is going to be 8 as well. So now this covers all the digits up to 1000. So let's just sum up the count of our 1-digit, 2-digit, and 3-digit positive odd integers with distinct digits. So it's just going to be 40 plus 5 plus 320, and that's just going to end up equaling 365. So of the first 1000 positive integers, 365 of them are both odd and have distinct digits, which is actually what I meant by this question, and I'll correct that in the actual question.